Well, last riddle, last video. What activity can only be done at night? And the answer is staying up at night. I read it and I'm like, what? Staying up at night. Yeah, I guess you can't stay up at night during the day. It has to be at night. So it's the only thing you can do at night. Staying up at night. Okay, well anyway, hopefully you had a chance to do examples 13, 14, and 19. And we'll do the rest of them in class, so make sure you bring your packets. And Trevor, this one's for you. You had asked me a question. Well, what happens when I remember how you asked me, is it possible for a series to converge only at the interval or the where it's centered? And this particular example, this is the one where it only converges at 0. And when you look at the series, you can see that x here is being raised to the nth power, so it's x to the nth. So this is centered at 0. So you automatically know that. And let's see here. Let's use the ratio test. And when you use the ratio test, you get the absolute value of x times the limit as n approaches infinity. Well, this only has an n up here, so you get x times absolute value of x times infinity, and that's never less than 1. Okay, so sometimes you do actually get that. So you get something that's never less than 1. Therefore, you say the interval of convergence is 0. That's where it's centered. Okay, and so it's not, there's no radius is 0, and it's not ever less than 1. But always remember, every series converges at where it's centered, at least. Okay, so example 14. Here's some work here. You get that you get the absolute value of x over 4 times the limit, and this limit here is 1. And so this is just like one of our other examples. This limit, this limit, absolute value of x over 4, is less than 1 when x is between 4 and -4. So again, we're trying to find the interval of convergence, and so we're not done yet. This is only the beginning. You have to also test the endpoints. Okay, so the rest of the work is done on another page. Checking the endpoints. When you check at x equals -4, you get this series. And what I always try to do, this is confusing to me to look at this series. So I always try to write it out. And you can see here that you've got an alternating series, and the terms are getting smaller in absolute value, and it's an alternating series, and the limit of the nth term goes to 0. So that's how you would say it. So yes, it converges at x equals -4, and then at x equals +4, this series diverges. Either use the limit comparison test or the direct comparison test. This series diverges, and therefore I didn't even write it. So therefore the interval of convergence, so therefore the IOC, interval of convergence, is from -4 less than or equal to x, which is less than 4. So that's how you have to write that. Okay? So there's your interval of convergence. And then for example number 19, this is the interval of convergence. Okay, so hopefully you got that right. Here's the work for the limit, ratio test. So we're using the ratio test to determine the interval of convergence. We get the absolute value of x -2. That has to be less than 1, so there's the work there. Let me see if you can see some of this writing here. Use the ratio test to determine the interval of convergence. Be sure to also check convergence at the endpoints. Okay, so this is our temporary interval of convergence before we check the endpoints. Okay, so we always have that. Checking the endpoints, I should have oh yeah, that's right, 1 to 3. And checking at x equals 1, there's the series there. It converges, it's an alternating series. At x equals 3, this diverges, okay? And you could say P series P equals 1. It's also called the harmonic series, 1 over n. I don't need to have that term, but anyway. So that's why we have convergence at 1 but not at 3. Excuse me. So that's a 5-minute explanation of those 3 problems, and bring those to class. Make sure they're right. Look them over again if you need to, but I will see you in class. Have a great night.